The graph below is the function f of x. Find the limit as x approaches 2 from the right-hand side of the function. Now, pay attention to the notation. We are approaching 2 from the right-hand side because of the superscripted plus above the 2. So this is an x value, so we're looking for where x is 2. So I'm just going to indicate that with a dashed line. It also happens to be an asymptote, but I'm not making it dashed because of an asymptote. I'm just highlighting this is where x equals 2 is. Now, I'm approaching x equals 2 from the right, which means I'm looking at values that are bigger than 2, but approaching 2. So for instance, if I see what happens with my graph, as my x values get closer and closer to 2, so x here is approaching 2, but what's happening to y? The y values are getting larger and larger. They're actually going off to positive infinity. And so that's the answer to this particular limit. It's going to be infinity. Now, be careful. There's a big misconception as to something that is infinity versus does not exist. So in terms of limits, if the limit from the left and the limit from the right will always be exist. They exist, all right? So they're going to be a number, or they're going to be positive or negative infinity. They will always exist. But it's the limit itself. If the one side of a limit is going to positive infinity, the other side of a limit value is going to negative infinity, those don't agree. That tells me that the limit does not exist. So the answer there is D and E. But if we're just dealing with left and right hand limits alone, those will always have a value. I guess I should be careful in saying they'll always have value, because there are certain situations where they might not, but yeah, those are fairly rare conditions, and you don't often run into those in a first level calculus course.